All right, standard 4.1, our first one, we can get the same base, so that's what we want to do. We can write 4 as 2 squared. Now that we have the same base, we do a power to a power. There's nothing to multiply the 2 by, so then we set our exponents equal. And we isolate x, so negative 2 equals x is our answer. Here, it seems like a base of 5 would be a great choice. Remember that when you have a fraction, it's the same thing as having a negative exponent. That's how we flip the base. Now we're going to do a power to a power. We have 2x minus 12 when we distribute the 2 to both, and then 5 to the negative x here. Now we can set our exponents equal and solve for x. And we get x equals 4. All right, it seems like 10 would be a good base here. So 100 is 10 squared. And then here we get 10 to the negative 1. Goodness. And we're timesing that by 10 to the x. Now we need to remember that when we multiply like bases, we add the exponents. So we have a little bit more than a power to a power to do here. So we get negative 2x plus 10 for this exponent. And here, when we multiply like bases, we add the exponent. So we're going to do negative 1 plus x. Now that we have the same base, we can set our exponents equal. And we are going to isolate x. So we get x equals 11 divided by 3. All right, 6 will be our base here. We're going to have 6 to the negative 2 on this side. And we still get x squared over here. We do a power to a power. We get negative 6x minus 8 here. Now we set our exponents equal. And when we have an x squared, we need to get it equal to 0 so we can factor. Now we need factors that will multiply to give me negative 8 and add to give me positive 6. Those numbers would be positive 4 and positive 2. So positive 4 and positive 2. And then we want to set those factors equal to 0. So here we get x equals negative 4 and x equals negative 2. When I plug in negative 4 right here, it gives me a negative, oh, I'm sorry. We don't have to check these. I'm going crazy. They're exponential equations. Those two answers are perfectly satisfactory. Sorry about that. All right. First things over here we need to do on 4.2 is to isolate the base. I've done that. I can't get the same base, so I need to convert. So we're going to have log base 5 of 7 equals x. And we're done because x is isolated. Over here we'll isolate the base. So we'll subtract 5 from both sides. We can't get the same base, so we take and convert this. Since I have a base of e, I'm going to use the natural log. So we have the natural log of 7 equals x minus 4, and then we'll need to add 4 to both sides to be getting x by itself. All done. All right, over here was a word problem. Brody came up with a model to model the number of TikToks he can make. If t is the amount of time in days, how long does it take him to make 100 TikToks? So we want to figure out how long it takes to make 100 TikToks. So we replace f of t with 100. So we can solve for time. We're going to divide by 0.632. And so over here, I'm just going to keep this because if I try to divide it, it's going to be a not pretty decimal. And again, we have an e, so we're going to convert to the natural log. And when I plug that into my calculator and round it to 2 decimal places, I get a little over 5 days to make 100 TikToks. All right, number 8, advanced. Each side is isolated already, so I need to go ahead and convert. So I have log base 3 of 7 to the 2x equals x minus 1. I have a power to a power right here, so I'm going to bring down that 2x in front of the log. I want to get my x's together. So I have this has an x term and this has an x term. I want to get those together. So I'm going to 2x log 3 of 7 minus x equals -1. So I just subtracted x from both sides. Now I'm going to factor out an x. And then I'm going to divide everything by 2 log base 3 of 7 minus 1. And so I get x equals -1 divided by 2 log base 3 of 7 minus 1. All right, in standard 4.3, I have logs on both sides, and I only have 1 in the very beginning one. Since I have a log on each side, and the bases are the same, I can set my arguments equal. And now I'm just isolating x. And I get x equals 1. Now, when I plug 1 into these x's, it gives me a positive argument. So it is great. All right, the next one, I have 2 logs on one side, so I'll need to condense before I can do anything else. And it equals 2x minus 1. Whoops, the natural log of that. Now that we have 1 log on each side, or natural log in this example, and the bases are the same, we can set the arguments equal. I'm going to multiply both sides by 4 to get rid of that 4 on the bottom. I get 8x minus 4, and now I need to isolate x. So I'm going to have 7x equals 7, so I get x equals 1. Now if I take this and I plug it in here for x and here for x, I'm going to get a positive argument. So this is an acceptable answer. All right, number 11, I see multiplying because I'm adding. So I'm going to have log of 2x minus 12 equals log of 6x minus 15. Make sure you distribute. So I have 2x minus 12 equals 6x minus 15. I get all of my x's together, and I get all of my numbers together. And when I divide that, I get x equals 3 over 4. Now, if I take this and I plug it into here, I'm going to get a negative number. So I actually have no solution for this problem. All right, last but not least, I have x minus 1 squared equals 16 when I do a power to a power. Now, when I multiply this, I'm doing x minus 1 times itself, and I need to make sure I distribute. So I get x squared minus 2x plus 1 equals 16. Now, this is a quadratic, so I'll need to subtract 16 from both sides. And I need factors of 15 that multiply to be negative 15 and add to be negative 2. So again, we want to multiply to get negative 15, add to get negative 2. So I'm going to have x minus 5 and x plus 3. So I'm going to have x equals 5 and x equals negative 3. When I plug this one in here, it's an acceptable answer. I get a positive argument. However, when I plug this one in here, I get a negative argument. So this one does not work. Only this one works. All right, on to 4.4. There are 2 logs on one side of the equation, so I know that I need to condense. So I'm going to multiply, and I'm going to get 8x plus 16. Now, notice I don't have a log on both sides of the equations. I have 1 log on one side and a number on the other, so I can't set the arguments equal because there aren't 2 arguments. There are only 1. So that tells me I need to convert. So I'm going to do 7 cubed equals 8x plus 16. 7 cubed equals 343. I know y'all have y'all calculator, and you checked me on that, so way to go. And we get 327 equals 8x, so x equals 327 over 8. When I check that, I take it and I plug it in here. It makes a positive argument, so it is an acceptable answer. All right, down here, I have a little bit more condensing to do. Here, I'm going to make this a power. So it is going to be 8. So we get 4x over 8 when we do our dividing. All right, and now we're going to convert because we have a log equal to a number. So 4 squared equals 4x divided by 8. So we have 16 equals 4x over 8. 16 times 8 is 128. And 128 divided by 4 is 32. And when I take this number, not that color, when I take this number and I plug it into this x, it is a positive number, so this works. All right, last but not least, these two. This already has a log isolated and a number on the other side, so I just need to convert. So my base is x, my x wanted is 2, and that equals 3x. I, again, have an x squared, so I need to make it equal 0. And then here I only have 2 terms, so I'm looking for the GCF. Well, x is what's common between both of these terms. And I'll set both of those equal to 0 and get x equals 0 and x equals 3. When I plug 0 in for this x, I get 0, so that is not a good answer. And when I plug 3 in here, I get positive 9. Positive 9 works, so I will check off only 3. Now, last but not least, I have one log on one side and a number, so I know I need to convert. We need to remember that the base here is 10, and understood 10. And we convert, okay? I have an x squared, so I know I need to make it equal 0. And 10 squared is 100. Now I need to multiply to get negative 100 and add to get positive 48. Well, 50 and negative 2 will do that for me. So I have x equals negative 50 and x equals positive 2. When I plug in negative 50 here, negative 50 squared, negative times a negative is a positive, so that is an okay answer there. And then when I plug in 2, I still get a positive number, so we are good to go for both of these answers. All right, time to go on and do your grow stations. Of course, if you have any questions about what you just saw, you should stop and ask us. Thank you.